It is given that the radiant energy from sun incident normally at the surface of earth 20 kilocalorie per meter square per minute. So the value of intensity of radiation, which is energy per unit time per unit area, is given as nothing but 20 kilocalorie per meter square per minute. What would have been the radiant energy incident normally on earth if the sun had a temperature twice the present one? So we know that the power which is emitted by the sun will be equal to E sigma A, temperature of sun raised to 4. So part of this energy is going to reach on earth's surface. So we can say that this intensity of radiation reach on earth's surface is directly proportional to the amount of energy which is radiated by the sun, and amount of energy radiated by the sun is directly proportional to temperature raised to 4. So you can write this I is directly proportional to T raised to 4. So you can write intensity in second situation by intensity in the first situation will be equal to temperature in second situation divided by temperature in first situation raised to 4. So in second situation, temperature we can take it as 2T, because in question it is given that this increased by 2 times raised to 4. So this T and T get cancelled, 2 raised to 4 we can take it as 16. So the value of intensity in second situation will be equal to intensity in first situation into 16, and in the first situation it is given as nothing but 20. So we can write 20 into 16, which is equal to nothing but 320.